How do archaeologists use thermoluminescence to date prehistoric layers? Imagine being able to tell exactly when a piece of ancient pottery was last fired or when a stone tool was heated for the last time. That's what thermoluminescence analysis helps archaeologists do. This technique is a way to figure out the age of certain materials found in prehistoric layers. It works by measuring the tiny amounts of light released from minerals in objects when they are heated. The key minerals involved are usually quartz and feldspar, which are common in pottery, flint tools, and sediments. The basic idea is that these minerals absorb natural radiation from their environment over time. This radiation comes from radioactive elements like uranium, thorium, and potassium present in the soil or within the object itself. As these minerals sit buried, electrons get trapped in tiny defects in their crystal structure. When the object is heated during its original use, like when pottery is fired or a flint tool is heated, those trapped electrons are released. This produces a flash of light called thermoluminescence. Scientists then carefully heat a small sample of the object in the lab. This process releases the trapped electrons, and the amount of light emitted is measured with sensitive instruments. The brighter the light, the more radiation the sample has absorbed since it was last heated. To find out how old the object is, archaeologists also measure the environmental radiation dose the sample has received over time. They do this by analyzing the surrounding soil and other environmental factors at the site. Once they know the total radiation dose and the annual dose the sample would have absorbed, they divide the total by the yearly dose. This calculation gives the number of years since the last heating event, which is usually the time when the object was last fired or heated. This method is especially useful for dating pottery, burnt flint tools, and sediments that contain minerals like quartz or feldspar. Thermoluminescence analysis is a helpful tool because it can date inorganic materials where organic dating methods like radiocarbon are not possible. It requires a small sample, usually about a few grams, which is heated in a laboratory setting. The process can take a few days to complete, but it provides a reliable estimate of when the prehistoric layer was created. In archaeology, this technique helps build timelines for human activity, such as when people started making pottery or using fire. It also helps date sediments that contain artifacts, giving a clearer picture of the sequence of events at a site. By combining thermoluminescence with other dating methods, archaeologists can better understand ancient cultures and how they developed over time.